Today we cover measures of center, most of which you've probably heard of before, and maybe whose definitions you already know, but we're still going to review them just to make sure we're absolutely on the same page. The arithmetic mean, or just the mean, or just the average, I'm sure we've all heard that term before, they're all the same thing, of a data set. Suppose we have points x1, x2, etc. It's the sum of those points divided by the number of those points. So I'm going to denote this as x bar equals x1 plus x2 plus blah 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 plus xn all over n. Okay. You might also see the mean written as mu equals, and I'll write the same thing. I'll mention this later. This just depends on whether we're talking about the population of values or whether it's a sample. Okay. Now, we often refer to the mean as the, mean or average. Right? Now, how is the mean useful, right? So, in other words, how is it the measure of center? Well, one thing you can note is that replacing all values x1, x2, etc. up through xn with x bar still gives mean x bar, right? i.e. x bar equals x bar plus blah, 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 plus x bar n number of times divided by n. Okay. The other way, and this is a little more conceptual, maybe a little more physical, like you think about physics. If we have a bunch of values, and you can think about weighted objects on a seesaw or whatever, but if we just have some values, it was like 0 to 10, I'm just going to make a number line over here, all right, etc. And suppose we have some points, right? Suppose we've got some kind of a dot plot going on over here. And I don't know, we have some values. And maybe, maybe our stuff looks something like this. The mean of these values, right, is the place where I could put a fulcrum. Maybe it's like, I'm just guessing, maybe it's like right here or so. So that if this were a seesaw or a scale, then it would be perfectly balanced. So it's the weighted middle, in a certain sense, of this fulcrum. So I'll say mean perfectly balances I guess, the number line or seesaw with fulcrum. Okay, just to let you know. And maybe I'll move this down a little bit, just to give it some space, okay? So those are two uses of the mean. We won't worry about that so much, but just know that the mean is a very important measure of the center in a certain sense, okay? Let's go ahead and use Minitab to find the mean ERA of all qualified Major League Baseball starters in, let's say, 2025. Okay, now a starter, I mean a starting pitcher. What you can do, and you can do this along, please, do this along with me, is open your browser and go to fangraphs.com. Fangraphs.com. And you'll get this. Now we're going to click on leaders. We're going to go to pitching 2025. Okay? You gotta love these pop-ups. Oh my gosh, so many pop-ups. They really want you to be a member. Anyway, we're gonna go over here. We can notice that we do have this ERA column right here. And if you really want to, you can click ERA, and then it's going to order it based on best to worst ERA. Paul Scans is number 1. No surprise there. Anyway, go to page size, change it to infinity. And then what we can do is we can go ahead, and we have to be a little careful about this. But we're going to select, we can't just export the data that's from members only. But what we can do is we can carefully select the data. Copy. Right, make sure you go from the bottom stat, that negative 0.04, up to the number 1. You have to get all that, but then copy it. Go to Microsoft Excel. Open it up. Let's just create a new spreadsheet. And I'm going to go down one right here, and I'm going to paste the data. Oh, look, beautiful. Right, that worked out so nicely. Now, the one thing is, just because of technical selecting things, I couldn't select the header. But oh, look, that's so nice. It's shaded in gray. So I'm just going to label that as the ERA, right? Okay, now what we can do is we can go ahead, and I just pressed Command down, press Control C to copy it, and now I'm going to open up. Oh, I guess I have only that. Let me see if I can find this. I'm going to open up the Excel file that has that allows us to do all our fun stuff. Oh, I might need to find this in an email. Hold on one sec. Let's open this up, and I'll post this on my classes for you to see. But we go ahead, we open this up. And we go to descriptive stat down here. And under data, let's just delete all this. You don't even need to press delete, but we're just going to paste the data in. Oh, okay, it looks like we're going to actually need to select all the different cells, right? And let's just paste all that data. Okay, there we go. I think that was the last. Hopefully that was the last of it. Let's see. I think there were 52 pictures, and yep, perfect. Okay, so you do need to select all the data points. But anyway, look, we have to select all the cells, but we have all 52 data points, right? We know if we go to Fangraphs, right? If we look at the number on the left, we had 52 pictures, and we're going from cell 11 to 62, so that is 52 values right here. Okay. Anyway, we don't even need to click any buttons. It just tells us the population mean is 3.809. Okay? So, in fact, I'm just going to screenshot this. All right, I'm just going to kind of screenshot it. I'm going to be doing this a little bit, right? Just honing in on this. Okay? Just going to copy that. Stick it in our notes. Right. Okay, and then the question is the mean ERA in the data set? Okay. Well, 3.809, let's just take a look. 3.809. And if we actually round that to 3.81, actually, that's kind of funny. There actually is a pitcher with a 3.81 ERA. That's pretty funny. So I'm just going to write rounding mu to 3.81, yes, mu is in the data set. And I'm just going to write in parentheses, by chance. Right? It just so happened that there's one of the pitchers who happened to have the precise mean ERA. In general, mu does not need to be in the data set. Okay. Right, as you know, just the middle might not be in the data set, right? Now, in the previous example, we found the mean for the population of qualified pitchers, so we used mu to denote the mean, right? That lowercase mu. In general, when you use Greek letters, you mean the population, okay? For a sample mean, we use X bar, right? In general, you use Greek letters for population numbers, like parameters, and we use English letters for sample numbers, statistics, right? And now here's a question: why do we consider both population and sample means, right? Don't we always want the population mean? Well, yes, but this goes back to the question of parameters versus statistics. Sometimes we can't find the parameters, and so we need the statistic to infer the parameter. I'll say precisely determine mu because we can't collect data from an entire population. So, and again, we will see this in a month or two. We'll be explaining these techniques over and over again. We find, I'll say, X bar of a random sample and use X bar to estimate mu, or maybe it's more precise to say a range of values for mu. Okay, but one thing I also just want to add, I'll put this in red here, is that sports is a great, I guess I'll say a great area for data collection because populations, right, like we looked at all 52 pitchers, 52 starting pitchers in major leagues, are large enough to be interesting or meaningful, but small enough to, I guess I'll say, for every individual's data to be collected. So periodically, I might reference sports teams or sports leagues, I should say. And it's not just because I'm a sports fan, although I am, but it's because sports is just a great sports websites are great databases for data, right? And so I might go back to that. All right, anyway, a more simplistic but still extremely important measure of center is the median. And I'm guessing that at least some of you have heard of that term before. If not, then totally fine. But the median measures the, I guess I would just say the, well, for lack of a better term, the middle, I guess I'll say the middle ordered value of a data set. Now, what do I mean by that? Well, if I say find the median ERA, I mean like if you were to order the data from first to last, so from first to 52nd, what is the exact middle of that data set? What's the exact middle value? Forgetting what the values actually are, just ordering them. So if I say find the median ERA, let's see what's going on here. So if we go back to the Excel file right here, now I'm just going to do a little bit of counting here, right? So if we have 52 data points, right, because we're going 11 through 62, the 26th, right, 52 divided by 2 is 26. So the 26, if you think about it, the first 26 data points are the first half, the second 26 data points are the second half. So the 26th and 27th data points will constitute the middle. Since we're starting on 11, right, instead of 1, we're just going to add 10 to that. So 36 and 37, which actually, just so happened to be the same thing. So I'll jot this down. I'll formally explain how I'm getting this in a sec. But for right now, I'm going to screenshot this. That, copy and delete, and I'm just gonna stick this guy right here, right? And sure enough, I just want to show you, I didn't actually even need to do that, right? I could have just looked over here. Let's see, do we have the median? Oh, we sure do. Let's screenshot that as well. Well, I don't want to really. Okay. Well, anyway, let's just copy and delete. Stick that right here. What? Try that again. There we go. Move that there. Move that there. And look, we have the same value. All right, let me just highlight it to emphasize. This is the same value as that. Okay. So actually, again, in fact, I'm just gonna copy this. Well, no, I'm not gonna copy. I'll just write it again. Okay. Sorry about that. Yes. By the way, I'll say the median equals M. So we're going to typically use this. We might also use Q2 a little bit later, but for right now we're going to typically use M. So yes, M is in the data set. In general, M does not, so it is in the data set, but in general, M does not have to be in the data set. Again, the middle does not need to be in the data set. Okay? Now, here's the formula for finding the median. First of all, or here's sort of the procedure, right? The real answer is just put your stuff into this Excel program and it'll spit it out for you. But what we really do is we order the data set. You have to put them in from lowest to highest. Now, you don't need to do that in this data set. I just happened to, but you didn't need to. It will automatically order it for you. But if I asked you to do this by hand, you would have to order the data set. You'd have to line them up. Then you have to determine whether the data set has an even or odd number of points. If the data set has an even number of points, then the median is the middle two values. I'll call them x n over 2 and x, oh shoot, no, I actually shouldn't say that. I should say, sorry. Let me move this over a little bit. I'll say the mean of the middle two values, x n over 2 and x n over 2 plus 1. i.e., the median, right over here, the median equals x n over 2 plus x n over 2 plus 1 all over 2. See how that's actually just the average of the two middle points? If the data set has an odd number of data points, then the median is just the middle value. It's just x n over 2 plus 1. Or actually, sorry, I shouldn't even write it like that. I should write it like xn plus 1 over 2. That's the better way to say it. That's the middle value. Again, the middle ordered value. So, when is the median in the data set? The median is in the data set if either A, n is even, and x n over 2 equals x n over 2 plus 1, right? The middle two values are equal. Or B, n is odd, right? If n is odd, then the median is automatically in the data set. Let's just do a quick example. The median, I'm just going to make this up on the fly, of the data set, I'll say this is, I don't know, -5, -2.9, 0, 8, 17, 18, 1, 2, 3, 4, 18, 20.8, let's say. Okay, so the median of this data set is, well, what? Well, let's go ahead and count them, right? 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8. Okay, so the middle two data points, right, it's going to be these guys, right? It's 8 over 2, right? 8 over 2, and then 8 over 2 plus 1, right? That's 4 plus 1, 5. Okay, so we're looking at these guys. We have to find the mean of those two guys. So we'll say 8 plus 17 over 2 equals 25 over 2. And if you want, you could write that as 12. And I think 25 over 2 is fine, but it's 12.5 or 12.5. Okay? There's the median of this data set is that. Right. So there you go. Okay. Now, again, in practice, you'll always have access to this Excel thing. But on the final exam, you might need to do it by hand. And so this is how you do it. All right, anyway, a couple quick observations about the mean and the median. One is not objectively better than the other. I might argue the median's a little more simplistic than the median, but it's better in a lot of the median's a little more simplistic than the mean, but it's better in some cases. And the mean is a little more complicated, and it's better in some cases. One thing to keep in mind is a measure is resistant if it is not sensitive to outliers. And we learned about outliers. Which one's resistant? Median is resistant. The mean is not. Okay? You could think of an example with a data set with crazy outliers, right? If I made this guy, suppose I change this to -500. Did I change the median at all? No, I did not. If I changed, if I took the mean of this, would I have changed the mean? I sure would have, because -500 is not included in the formula for the median, but it is in the formula for the mean. So one thing I want you to think about is, when is it a good idea for a statistic to be resistant, and when is it not? Right? This is something for you to think about. I'll talk about this in class. Lastly, we have the most simplistic measure of center. The mode of the data is the most common value. That's it. How does the mode appear on the graph? The mode is the highest value on a frequency, I guess I could just say on a histogram, I guess I'll just say. Or dot plot. Right? It's just, you've got this and this, and maybe we dip down a little bit, go up here, and then maybe we go back down a little bit. Let's try that a little better. Right? We'll call this guy, I guess, capital M, maybe. That's the mode, right? Because it's the highest value. Or, sorry, I lied. That is not the mode. That is the frequency of the mode. Lied about that. Call this M. Right? It's the highest value. This is the frequency of the mode. Okay, but it's not the mode itself. This value right here is the mode. Okay? Now, if multiple classes are tied for the highest frequency, then they're all the mode, with one exception. If every class has the same frequency, then the data set has no mode.